Okay, so let's recap, right? 3 plus 3 cosine theta. At theta equals 0, I have my maximum radius. Then I have a minimum radius of 0 at pi, and then a maximum radius. All right, if you just translate that mentally onto the polar graph, when theta equals 0, my radius is a maximum of 6, okay? And then, as I move closer to pi, the radius gets smaller and smaller. So look up here for a minute, and let me show you what's happening. You have your biggest radius here, and then the radius is getting smaller, 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 smaller to 0, okay? And then what happens after that? The radius starts to get bigger again. So from here, the radius gets bigger, 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 bigger. All right? So that's what's happening. Now, let's plot that here. So at theta equals 0, radius is 6. That's not 6. I'm going to label these as 2, 4, 6, 8. So 6 is here. And then at pi over 6, we're at 5.6. Pi over 3, 4.5. Pi over 2, 3. And then 2 pi over 3, 1.5. 5 pi over 6 is 0.4, and then 0. Okay, so if I trace this, take a look at what's happened. You see what's happened? You see how it curved in? So I have a big radius, smaller, 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 smaller. It curves into itself. Okay, now the bottom, okay, it's going to be symmetric, going in the opposite direction. At 7 pi over 6, it's 0.4. And then it's 1.5. And then it's 3. Wait a minute. 3. And then it's 5 pi over 3, 4.5. It is, though, because look at what's going to happen now. 5.6 here. And then back to 6. Right? So look at that. If I make it closer, it is exactly like a heart, isn't it? Right? And now do you see why it's a cardioid? Right? It's a cardioid. So this is the case when you have a plus b cosine theta, and a and b are equal. So you see how there was a dimple in here, right? Because it has to be, because as you approach here, the radius starts from a maximum and goes to 0. Okay? So you're gonna think about that distance as a radius from the origin. Okay? Now, so to see the same thing, one more time, simultaneously, this is the case when a equals b, right? So this is 3 plus 3 cosine theta. This is what we just graphed, right? So when I start this animation, it's going to trace this cosine graph on the Cartesian plane, and at the same time, draw the graph here. So you see the corresponding points. When theta equals 0, the distance from the x-axis is a maximum. So here the radius is going to be a maximum. All right? And so on and so forth. So then you see here, right? Now the radius is getting smaller, 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 smaller. And at pi, the radius is 0. And now the radius is going to get bigger and bigger and bigger as the Cartesian graph gets farther and farther from the x-axis. So you see that? That point corresponds to that point over there. And now as we near 2 pi, the distance in the blue is getting largest, is going to be the largest, so the radius in the green is going to be the largest. Okay? And right there. Okay? Yeah.
Is the radius always going to be from the
pole? Absolutely. That's the whole point of it, is that the radius is always from that pole, the origin, which is the pole.
Even if you have like something else. Like...
Yes, you'll see as we do more, you'll get into the habit of it, okay? All right, let's take the second case when A is greater than B. So you can see clearly 4 plus 2 cosine theta, A is greater than B, all right? So let's do this one. Okay, when theta is 0, cosine is 1, so that's 4 plus 2, which is 6. At pi over 2, cosine is 0, so the whole thing is just 4. At pi, cosine is negative 1, so 4 minus 2 is 2. At 3 pi over 2, cosine is 0, giving us our 4. Okay? At 2 pi, it's 6, maximum. Okay. Let me graph this without crowding it too much. So we start at, I meant to write 6 over there. All right, so we start at 6, then go to 4, then go to 2, back up to 4, back up to 6. Okay? All right, let's take a look here what's happening. Okay? Let's look at some trends now. All right? So at theta equals 0, right? You have a maximum radius, right? Because the graph is farthest from the x-axis. Maximum radius of how much? Right. And then what happens to the radius? Does it get bigger or smaller? Smaller. Smaller, smaller, until what minimum value? 2. This time it does not go to 0, right? The radius this time does not go to 0, right? So as what is it? Theta approaches pi, r approaches 2. That's the minimum value. Okay? Not 0 this time. Okay? And then what happens as theta approaches pi over 2 pi? Right. Radius increases again to maximum of 6. Right? So like the exact wording over here isn't the point, it's the concept, right? Okay, so when we fill these in, we get 5.7, 5, 4, and then 3, 2.3. And then it's going to repeat again, right? After pi, so 2.3, 3, 5, and then 5.7. Okay, it's very helpful, it's very useful to be able to visualize this before you draw it. Okay? So first we have a maximum radius of 6, right? Then that radius is going to get smaller, 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 right? Like it's going to get smaller and smaller, but the smallest at pi is going to be a 2, right? And then it's going to get bigger again until it reaches the maximum. So do you see that? So we start at a high radius, and then it gets smaller, 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 but not 0. Okay? The smallest is going to be a 2. All right, let's graph it. Let's graph it and see what it looks like. Again, we're going by 2s, so this will be the 6. Then 5.7, 5. That's the center of those two lines. And then 4, and then 3, 2.3, and then 2. Okay. So obviously there is a little bit of eyeballing and estimating here, right? Obviously, because I don't know where 2.3 or 5.7 are. The point though is recognize that it's symmetric horizontally or vertically. And then, just make sure that you mimic or that you mirror properly. So then here, we're going to have at 7 pi over 6, 2.3, and then 3, and then 4, and 5, and 5.7, and 6. So it's going to come up here. Okay? So the other one had a pronounced dimple. What's it over there? This one is more, see, like this one had an actual dimple. This is more of a, I don't know what you want to call it. It's more subtle, right? So we have a very small, we have a small number of points here. But if we look at another animation, okay, A is greater than B, same exact one. Here, there are a lot more sample points. So take a look at what it looks like. Look, radius is getting bigger, 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 bigger. Smaller, smaller, smaller. That's the minimum radius. That's the minimum radius of 2. And now it's going to get bigger. Okay, so you see what that looks like? Okay, it's like it's like when you're pressing against the side of a balloon. Okay? All right, question.
Does it look the same for sine? Like how do you know what that looks like? Sine would be on top of bottom.
Oh, she just stole my stole my moment there. So cosine is a maximum when theta equals 0. Here, sine is a maximum when theta is pi over 2, so it'll be, yeah. All right. So let's go to another one. Okay, the case when A is less than B, here. Okay, so here, when theta is 0, we have 6 again. Then theta equals pi over 2, it's 4. Theta equals pi. Now cosine is -1, right? So it's 2 minus 4, which is -2. And for the first time, we have some negative values here, right? And then at 3 pi over 2, cosine is 0, so we get a 2. And then we get our maximum of 6. Okay.
Wait, why is there pi over 2? Why is it 4?
Yeah, why?
For which one?
Pi over 2.
Oh, it's 2.
I think it is 2, yeah, that makes sense.
Okay. It's 4. It's 4 here. Okay. So we go from 6 to 2 to -2, back up to 2, and then 6. All right. So this is what it looks like. All right, now let's try to visualize this. At theta equals 0, I have a maximum radius of 6. Then, as I approach 2, and then the radius starts to get what? Bigger or smaller? Smaller.
Until pi.
Until?
Pi at 2, and then.
Well, okay, so
negative.
it's 0 before pi, right? And then at that point, here, somewhere here, the radius is a negative number. So smaller, 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 and then it's negative. What happens when it's negative? Opposite side, opposite side, okay? And then it has to make its way back out of the negatives into the positives. Right? And then get bigger and bigger. Okay, so let's see what that's going to look like. So if I complete this, it's 0 at... Okay, so let's see what it's going to look like. It's 6 at 0. And then 5.5. And then it's 4. Afterwards, at pi over 2, it's 2. And 2 pi over 3, it's 0. Okay? At that point, at 5 pi over 6, it's not positive, but negative 1.5. So it's going to curl inwards. Negative 1.5 here. And then at pi, it's negative 2. So let's take a look at what happened. Came over here to 0, negative radius, and curled this way. So it's almost like a spiral. Now let me continue the rest in blue. At, where are we now? At 7 pi over 6, okay? Again, it's negative 1.5 at 7 pi over 6. So where is it? To the left, to the right, right? So it's here. And then at 4 pi over 3, it's 0. So look at what happened. Do you see what happened? Right? So then at 3 pi over 2, it's 2. Then 4. Then 5.5. And then, isn't it cool? Isn't that cool? So it makes a little loop inside. Okay? So let me show you here. So basically some trends here. There is maximum radius of 6 at theta equals 0, right? Okay? And then r is 0 at what? Theta equals 2 pi over 3. Okay? And then it can, okay, so radius continues to decrease and is negative, right? So r is less than 0 between what and what? So basically between 2 pi over 3 and 4 pi over 3. Okay, so it goes into the negative direction, and then it's positive again. So if I were to show you that animation, look at what it looks like. So this is the case when A is less than B. So look. Okay, so here it's 0, and then it's going to curl inside. Right there, loop inside, and then make it back out into the positives. Okay? So it's making that inside loop in the time that it's negative under the x-axis here. You see that? So that loop is being made when it's under the x-axis here. Isn't that cool? Yeah. And then here it's making the outside loop. Okay. Whoops. All right, and so Claudia and Jesse jumped the gun on this, but we just talked about the fact that when we're talking about cosine, cosine is a maximum at theta equals 0, so it's here, and then sine is a maximum at pi over 2, so that's what sine looks like. Okay, roses. Ready for roses? Okay. The first thing we talked about were circles, remember? And we said those had the form A cosine theta, A sine theta. So that was just A cosine theta. Now if you have A cosine n theta, right, that gives you the graphs of a rose, or graphs of roses. So r equals A cosine 1 theta is a circle. So obviously n has to be greater than or equal to 2, right? So it has to be A cosine 2 theta and on in order for it to be not a circle, a rose. Okay? So it has to be that such that n is greater than 2 and it's an integer. Now, roses have petals, okay? The rose is going to have n petals if n is odd. So for example, A cosine 3 theta, 5 theta, these have 3 and 5 petals. 2 n petals if n is even. So if it's cosine 6 theta, 12 petals. How many petals here? 4 petals here. Okay? All right. So,
never have 2 petals.
right. Huh? Right. Okay, so what I'm going to do first here is label this as pi over 2 pi. I meant to change it, but I couldn't. 3 pi over 2 and 2 pi. Okay? Now, this is cosine 2 theta. So if it changes between cosine theta and 2 theta, what happens to the period? How much is the period of 2 theta, greater or smaller? Period is smaller, so how many can we fit in 0 to 2 pi? More. How much more? 2, right? Twice more. So for cosine 2 theta, basically, how is this going to look? It's going to be, right, so it's going to complete one cycle from 0 to pi, right? So if it's a maximum here, it's a maximum there. So it's a minimum here. Remember? So zeros are here. And same thing there. So that's going to look like this. Okay? All right, so I didn't put a trends box here, but this is super important. Radius starts off at 0 or maximum. The radius starts off at maximum, goes to 0, back to maximum. Okay, so when we talk about radius, right? Let's talk about, minimum or maximum. Basically, is it close to or, farthest from the pole and so on. So maximum radius, 0, gets bigger again, 0. Maximum again, 0. Maximum, 0, maximum. So do you see? Okay. So now, okay, let me, if we, do these. 2, 4, 2, -2, -4, -2, 2, and 4. Now, look at these points, though. Where are these points? What values are those? The blue ones, what values are those?
0.
Not 0, like, oh, I'm sorry, not value. What angle?
Oh. Pi over 2,
pi over 4, 3 pi over 4, right? And then 5 pi over 4, 7 pi over 4. Okay? I want to put those in as well. So, when theta is 0, maximum radius is 4. When theta is pi over 6, this is not negative, it's positive here. When theta is positive 6, the radius is 2. When it's pi over 6, the radius is 2. Now, pi over 4 is here in the middle, right? Okay. At pi over 4, the radius is 0. Okay? So look at what that looked like right now. Do you see that? Okay? Then pi over 3, the value is -2. Right? So pi over 3, the value is -2, so we go here. Okay? -2 right here. And then we have pi over 2 is negative 4. Whoops. Pi over 2 is negative 4. Here. 2 pi over 3 is negative 2. And then over there, where did my colors go? Over here is 3 pi over 4, okay, which is where it's 0.
So whenever it's 0, it goes.
Right. Okay, so here it's going to go this way, here, okay. Now, so we hit 0 there, and then it's at 5 pi over 6, it's 2. Pi, it's 4. Okay, so look, we're here now. Okay, and then 7 pi over 6 is 2. And here, between 7 pi over 6 and 4 pi over 3, there is another 0. And that's 5 pi over 4. And here there is 7 pi over 4. Right? Every time it goes between positive and negative. So there we have a 0. So now it's going to go back to 0. So do you see that each time it's going far and 0? Far and 0. So where is it going to go from here? From 0? It's going to go far, 0, far. Okay? So next one at 4 pi over 3 is negative 2, so that's here. 3 pi over 2 is negative 4, so that's up there. 5 pi over 3, negative 2. So look, we go back up and back down. And then at 11 pi over 6 is 2 and 4. Okay? So, this one should have been at 4. 3 pi over 2 should have been at 4 up here. So, each time, look at me tracing it. It starts from far, 0, far, 0, far, 0, far, 0, far. Okay? Maximum, 0, maximum, 0, maximum, 0. We can do this all day, but we're not. This is a summary of roses here. Okay? So look. The one we just did was cosine. All right? And do you see how the cosine is a maximum at 0? So cosine is a maximum at 0. You always have a maximum here for cosine. Even and odd. Okay? For the sine, right, you don't have it on the x-axis. Okay, you don't have it on the polar axis. So let's take a look here. Okay. Okay, cosine. So this is the exact same one that we just did, right? And take a look. Far, 0, far, 0, farther, 0, back to the maximum, back to 0, and back to the maximum. Okay? Yeah. So next, take a look here. Yeah, it'll go forever. Okay, parameters BNN. So this is 4 cosine 2 theta, what we just did. Okay. So B, that's 4. So let's see what happens if B is less. Right? That's the radius. Okay? And if I increase B, the radius just, everything stays the same. The radius just gets bigger. Or, you know, how far it is just gets bigger. And then what about 2? So 2, n is even. All right? So we have 4. Now 3, how many are we going to have? 3. Look at how it looks. Okay, and this is cosine. So cosine is always going to have 1 on the polar axis right there. Okay? And then 4, how many are we going to have? 8. And 5. And 6. And 7. And 8. And 9. And 10. Okay?
Is that 20 roses?
20 petals, not roses. 1 rose, 20 petals.
Make it really small.
So true.
Okay? Okay. I need to show you this before you leave. Cosine and sine 1 theta, this is our circle. 1 petal, circle. Get it? 1 petal, circle. N equals 1, n equals 2. So take a look at the cosine. There's always 1 on the pole, but the sine, there isn't. Okay? And then n equals 3. You have 3, 3. Look at that. Where the cosine's first one is and where the sine is. 4, 5, and so on. Okay?
So sine will never have one on the axis?
No. No. All right, we'll stop here and we'll continue tomorrow.